Now, another important characteristic of microphones is their pickup pattern. And what this ultimately is where a microphone is looking for sound and where it's not paying attention to the sound that's around it. So in these charts, I have a gray area that represents the pickup pattern type, and then this would represent 360 degrees around the microphone, the white circle. So knowing what the pickup pattern is of your microphone is really helpful because you can use different patterns in different applications. You can focus the microphone in on something very narrow like a voice or one person, or you can use it to record a whole room, or you can set it up in situations where you have sound sources in certain areas that you want to get, but other sounds in the same room maybe that you don't want to get. So picking the right pattern and knowing what the pattern is of your microphone has a lot to do with how you determine which one to use and where to place it based on its pattern. There's I'll call them three big patterns that you'll get used to: cardioid, omnidirectional, and bidirectional. These are the most kind of common families, so to speak. And really, omni and bi, they aren't really families, they're just their thing. But cardioid is kind of a family, and cardioid actually refers to heart. And you'll notice it's kind of heart-shaped. So there's three: cardioid, supercardioid, and hypercardioid. The difference between these three is really how much they reject on the side and how much they reject in the back. You'll notice that sounds on the cardioid, if they're coming in from the side here, will get picked up a little bit more than they will on the supercardioid. And the hypercardioid's trying not to hear them very much at all. And also the hypercardioid is focused more towards the front. So sounds coming from around here, it's not as sensitive to those. Whereas the cardioid, if you're over here, you're still going to be heard pretty well. The trade-off on the super and the hyper is that they have this little mushroom stalk here that picks up the stuff immediately behind it a little bit. It's a trade-off. If you're trying to focus a group of vocal singers, you have three singers next to each other, they each have their own microphone, you can use a hypercardioid. That way, one singer's voice doesn't get into the other microphone. You'll use this a lot on things like guitar amps, drums. Almost all the drums you'll use some sort of cardioid pattern on, even bass amps. There's all kinds of applications, acoustic guitars. You can think of cardioid really as directional or kind of pointed at something. It's kind of like a gun in a way. You can aim it at something. The opposite is the omnidirectional, which picks up evenly in all directions around it. So this is good if you have a group of singers and you want to spread them out around one microphone. It's also good if you want to record a drum set in a room and you have a bunch of close mics on it, but then you want to put one back and get kind of the ambience and the effects. An omnidirectional mic in the room can do pretty well. And it's also good for actually handheld interviews when you're out moving about on the street, like if you're walking next to someone and trying to hold a microphone in their face. An omnidirectional microphone is more forgiving when they move and turn or when you move the mic up and down. Actually, you get a more even sound. The catch-22 is you're going to pick up the cars down the street a little bit more. But when you listen back, it's that evenness of the pickup that actually makes that a more listenable interview in a way, and that you don't have big volume changes where all of a sudden you can hear the person talking and then you can't hear them as well because they've moved from the microphone. So Omni is actually really useful in certain circumstances. A lot of times, though, in live circumstances where you're trying to avoid feedback or leakage, omnidirectionals don't come into play that much. The bidirectional or figure 8 pattern picks up to the front and the back of the microphone and rejects both sides. So this is convenient if you want to put two people around a microphone for an interview session. Also, if you have one microphone and need to record things like two toms or something like that on a drum set and you just want to put one in between them, this can work. Although it's usually not available on a lot of dynamic microphones. Many condenser microphones will give you the option to switch between cardioid, omnidirectional, and bidirectional. And I'll show you an example of those kinds of microphones later. The last one I want to talk about is the hemispherical pattern, which basically is a pattern that's associated with a pressure microphone or a PZM microphone or a boundary microphone, which is basically something that you put on a flat surface and that surface becomes the pickup. So for instance, this represents a little microphone that you would put on, say, like a boardroom table, and all of a sudden everyone talking around that table gets picked up in this hemispherical pattern around that microphone. They use them a lot in theater situations where you want to hear people walking on stage or sound effects, but you don't want a bunch of microphones pointing at the actors. This picks up kind of the overall ambience of what's going on the stage. Sometimes you'll see them used in recording studios. They'll hang them on walls to pick up drums. different walls like opposite a drum set to get a room sound, or if you're doing a symphony, you can put a few of them on the wall and just get different hemispherical pickups in the room where the symphony is. You can also see them on the walls of studios to pick up big drum rooms or rooms with ensembles or even orchestras. Knowing about patterns will pay off for you in terms of focusing your microphone on the sounds you want to pick up and the ones you want to reject, the ones you don't want to get into your recording. It's good to kind of study these, get to know them. You'll see icons on microphones that represent these patterns. They look here, they're a circle, they're a cardioid heart, they're the figure eight. But they're good to know and good to think about when you're picking microphones for your applications. The next thing I want to talk about is the polar pattern graph, which is used to represent the sensitivity of microphones to different frequencies in relationship to their polar pattern or their pickup pattern. So in this slide, we have what you'll get if you buy a microphone. You'll probably get this in the specs, the polar pattern. And what it shows is just the different degree of sensitivity to different frequencies at different points around the pickup pattern. So this is a cardioid pickup pattern, and what it's saying is that this thick line is the 1 kilohertz frequency. At that frequency, it's sensitive in a true cardioid pattern. Now, if you look at this line, which represents 8 kilohertz, a higher frequency, it's actually more sensitive to that back here where it's supposed to reject it. So if you have higher frequencies, you're actually going to hear those a little bit more. They'll seep through and have more presence in what you're recording than like the 1K will. It won't be rejected as much as that frequency. So this is more or less the sensitivity footprint of your microphone. And it just kind of lets you know where it's listening and what it's listening for, kind of the directionality of it. In the next section, we'll talk about axis, or where you're pointing your mic in relationship to where the sound source is coming from.